It was y equals x squared minus 1
Okay?
over x squared minus 2x plus 1.
Alright, let's see what this one looks like. I could start noticing a few things, but I'll try and go in order. For one thing, it's the same degree, top and bottom, but I'll factor first. What's going on the top? X plus 1, x minus 1. Jan, were you about to say that it's difference of squares?
Huh?
Were you about to say that it's difference of
No, I was
squares?
about to say the exact same.
Okay. How does the bottom factor?
The same way. Or no, it was x minus 1, x plus 1.
On the bottom?
Yeah.
Bottom should be x minus 1, x minus 1. That's
Yeah,
your...
yeah, that's what I was talking about.
Which number?
Okay.
Yeah.
This is number, which number was this?
40, I believe.
40, I'm being told. Okay.
Yeah.
So first thing we notice is we have the same factor top and bottom, so can we completely forget about that? Can we?
Well, we know that that means that there's going to be a discontinuation.
A discontinuity there, yeah.
Oh, yeah.
But then there's also vertical asymptotes you still have.
At the exact same spot, right. So that jump discontinuity is actually going to be sort of erased, overwritten by the vertical asymptote there. All right, let's start getting a little more formulaic here. What's the first thing I said to find?
The y-intercept.
Y-intercept. I think that's easiest because you go to
Plug
the...
in 0.
Pardon?
Just plug in 0.
Yep, plug in 0 for x, and everything with an x in it disappears. I like to go to the unfactored form for that, and when everything disappears,
Just -1.
all you're left with is -1 over 1 or -1. So that's the y-intercept. What's the second thing I asked you guys to find?
Horizontal asymptote.
Horizontal asymptote.
And since they're the same degree, it's just 1.
Very good. Since the polynomial on top is the same degree as the polynomial on the bottom, you go by the ratio of the leading coefficients. So that's going to be y equals 1 over 1.
1.
For the test, are you going to grade our steps to see that we got the right one for the steps, or are you just going to look at the graph?
It depends. Sometimes I write this out on the test. If I write this out, then I'll go step by step, which should help your grade.
That would be nice.
Sometimes I give you guys this page just like for help on it. If I just give you a blank sheet of paper and the problem, then I would just look at your graph. But you have to label it very clearly. What's the third thing I said you guys should find?
Vertical
vertical.
asymptote.
Vertical asymptotes.
It's pretty much
Yeah, there's only one vertical asymptote, and that is at x equals +1, because we found that with whatever made the denominator 0. So if the denominator was made 0 by +1, that's where we get a vertical asymptote. Normally, if you have a 0 on the top and a 0 on the bottom, you get that jump discontinuity, but that won't happen here because the vertical asymptote erases it.
It pretty much evolved into vertical asymptote.
Evolved into, I like that. It's very like X-Men like. Okay, what's the fourth thing I said you should find? X-intercepts. And the
How
X,
do you get horizontal asymptote?
the horizontal asymptote, if it's the same degree, top and bottom,
Oh yeah,
second degree, the polynomial, largest exponent, top and bottom,
that's just 1.
you go by the leading coefficients. So if this were 5x squared over 3x squared, it would be 5 over 3.
Forgot about
1x squared, so it's just 1. The x-intercepts
What
are,
makes the top 0?
very good Tyler, the x-intercepts are whatever makes the numerator, the top 0, as long as it's not 0 over 0. So, only thing I see is if x is equal to -1, we will get a 0 on the top. It's the fifth thing I said to look for.
Wait, what is 3? How did you get the vertical asymptote?
Vertical asymptote, whatever makes a 0 on the bottom.
Oh, so that'd be positive.
+1.
And then the other one is the one on the top.
That's the x-intercepts are the zeros of the vertical asymptotes,
Oh, that's weird.
are your zeros of the denominator. And your x-intercepts are your zeros of the numerator.
Why don't we do x-intercepts first and all that?
I just do it in the order that I find easiest, but it really doesn't matter,
Okay.
as long as you're careful.
Yeah.
I think, what was I saying? Oh, I like to do the first two because I find these easiest to do in the unfactored form. And then I go and start looking what is easiest to do in the factored form. That's why I picked that order this year. What was the fifth thing I said to do?
Sign analysis?
Sign analysis. We're ready for that? Okay. I only have to deal with these two factors. The factors that cancel up here are, no, they canceled. They're not part of it anymore. Incidentally, normally when I cross out the same factor top and bottom, I write myself a note here that says x can't equal whatever would make those two factors 0, because that's your jump discontinuity. I didn't write it this time because we already knew that because of the vertical asymptote on the bottom. Sign analysis. Okay, I've only got the two factors, x plus 1, make a number line, x minus 1, make another number line, and then the entire function, make a third number line. And let's see, I'm interested in 0 on all three number lines. Now, x plus 1 is interesting when x is negative 1. X minus 1, interested when x is positive 1. I didn't do it this way last time, did I? I put these on the bottom, and I put the pluses and minuses on the top. I like to try and be consistent. Okay, and I'll be interested in what happens at negative 1 and 1 on the entire function. Okay, if you have an x value less than negative 1, you just put it into the binomial x plus 1, you know your answer will be negative. When we get to negative 1, we have a 0. This binomial will equal 0, and if we're anywhere to the right of negative 1, if x is larger than negative 1, then this binomial is positive. For x minus 1, that will be negative if I plug in any x value less than 1. That will equal 0 at 1. And if I put any x value in greater than 1, I get a positive number. Looking at the whole function, x plus 1 over x minus 1, to the left of negative 1, I will have a negative divided by a negative, and what will that give me?
Positive.
Positive, Jen says, and I believe her. At negative 1, I'll have a 0 in my numerator. It's going to make the function equal to 0. Between negative 1 and 1, I have a positive divided by a negative.
That would be a negative.
That would be a negative. And when x equals 1, I have a 0 in my denominator.
That's
An asymptote, so I like to write UND for undefined. And then everywhere else, to the right of 1, I have a positive divided by a positive, which is a positive. Think we have enough information to graph this thing?
Yeah, my issue was how to transfer the sign analysis to how you graph it.
All right, and let's see what we can do with that. Okay. I don't know why I'm switching colors. Mood just struck. Okay. We'll go out about 2 units in every direction. That might not be enough on the Y. Actually, I'll hold off on the Y scale for now. All right.
It doesn't matter.
Start with our y-intercept.
Y-intercepts, very good, -1. So let's pick a Y scale. Here we go, that's my Y scale. There's -1, there's my Y-intercept. Horizontal asymptote, then, is Y equals +1. So I'll label that. vertical asymptote at x equals positive 1.
And there's a point discontinuity on 1.
There is a point discontinuity there, but it's going to be erased by the vertical. We're not going to see it because it's wiped out by the vertical asymptote. X-intercept -1, got that. Okay, so now we start thinking about how we use the sign analysis.
The x-intercept is -1.
X-intercept's -1. Okay, good. I know I was forgetting something. All right. I know that if I go to the left, this function is getting closer to this horizontal asymptote. Means if I go to the right, I should start close to this asymptote and move away from it. Then, let's do this in colors. Let's stand out a little more. It's got to hit its y-intercept, then it's got to hit its x-intercept.
Wait, can you explain this? Sorry, can you just go like step by
Yeah,
step
really
of
fast.
like, okay, whatever to -1.
I was saying it fast and I was drawing it too fast and it wasn't coming out very well. Okay, we know that when we have x less than -1, the entire function is positive,
Yeah.
okay? We also know that as we move to the left, the function has to snuggle up to this asymptote.
Right.
It's got to get closer to it. So I'm going to start at the x-intercept. I'll do this a little differently how I just started to. I'm going to start at my x-intercept because I know the function's there. And I'm going to draw it getting closer to the asymptote as I go left. Some functions do cross their horizontal asymptotes, but we're not going to worry about it. This one, ones with polynomials, top and bottom, well, it can happen, but that's not going to happen on this one, I don't think. Now, after I get to the right of -1, okay, from -1 all the way to +1, I know the function is negative. I know it hits the y-axis here at -1, and then I know it has to snuggle up to this vertical asymptote. So,
So we know it's negative until 1.
yep,
So
not just negative, but increasingly negative. Because if it's negative as it approaches a vertical asymptote, it's got to head down towards -infinity. Once we get to the other side of 1, it has to be positive, and it's got to snuggle up to this vertical and this horizontal asymptote. We know it doesn't hit the x-axis anywhere because we would have found the zeros.
So that's what, why does it have to? Why do we know it has to be in that corner, not there?
Well, let's see, two things. It has to do one of these two things. I'll put two possibilities up in green. It's got to go from the vertical to the horizontal asymptote, right? That's the definition of an asymptote.
Yeah, I know it has to be either that or that, but how do you know which one? Yeah, you know it has to be one of them, but how do you know which one?
Okay, two things. Did we find any zeros, any x-intercepts bigger than 1?
No.
Okay, so it can't hit the x-axis anywhere here.
Oh.
2, when you're to the right of 1, can this function be negative? On our sign analysis, we said it had to be positive everywhere to the right of 1.
So it's the bottom one?
Nope, it's got to be the top one. Because it can't hit the x-axis,
Just the
and it can't
x-intercept
be
is
negative.
What are we counting as positive?
The actual function itself, the y value. That's a good question, actually. I say that, and I forget to mention that. F of x, the result, this is y. After we figure out how these factors are going to play out and make each part positive or negative,
So all of y has to be positive.
y has to be positive, the y value has to be positive till we get to -1, the y value has to be negative from -1 to 1, and the y value has to be positive when we get to the right of it.
Wait, so it has to be, it can't hit that, be there on the bottom because it can't hit the x-axis because there's no x-intercept there, and why else?
And it has to be positive the entire way, and if it were down here, it would have to be negative in order to snuggle up to this vertical asymptote. So because the y values have to be positive, the only, I don't want to say the only possible because there are other functions. For this particular function, the only possible behavior is that it looks sort of like y equals 1 over x up there. This is not possible because we don't have an x-intercept and we can't have any negative y values on this side of x equals 1. And that is the graph for number 40. You think you follow those steps, you should be fine. I think we can do one more of these.
Can we do 38 then?
Well, which one's uglier?
38.
Let's do the uglier one. Is that the one with the slant asymptote?
Ugly duckling.
No, actually.
Let's
I don't know, whatever you guys wanna do, 36.
Let's do 30.
I'll take a super quick look at them both.
I don't know, 38, they gave us this whole, like, I don't know. is
Oh, they gave it to you in factored form.
Yeah.
That will be, that's an interesting one. Are you sure both those are squared?
Yeah.
Oh, yeah.
Okay. Alright, well, read it to me. Let me see what it
Y
is.
equals.
I'm sorry, I said that too soon. Okay, 38 we're looking at?
Yeah.
Y equals.
X minus 2 squared, and then squared.
Mhm.
X plus 1 squared over x minus 2, x minus 1.
X minus 2, x minus 1. Oh, okay, I see what they did, that's right. This one, okay, now that one done. So close. Okay,
I FOILed everything out, and then I realized that was probably the dumbest thing I could have done.
No, I did it
might
too.
have helped you in one way, but first thing I'm gonna do,
Help you see that it was a slant asymptote.
But it wasn't.
oh, actually it will be, I think.
What?
Well, first thing I would do is go ahead and cross out an x minus 2 top and bottom, since we have x minus 2 squared. And then I write my little x can't be positive 2 reminder, because I think that will be a jump discontinuity there. Although how that affects that is going to be interesting. Now it's not going to be a slant asymptote still, it's going to be too big. If you FOIL this out, you should get x minus 2 times x squared plus 2x plus 1 over x minus 1. And then this last one will be x cubed,
Right.
and that's going to be plus 2x squared plus x minus 2x squared minus 4x minus 2 all over x minus 1.
It has to be exactly 1 degree higher to make it a slant.
And how many degrees difference do we have here, Tyler?
2.
Yep. You really get a plus 2x squared and a minus 2x squared? That canceled? Okay. Minus 3x minus 2 over x minus 1. And Tyler's remembered the rule correctly. In order to have a slant asymptote, you need a 1 degree difference. This has a 2 degree difference. So this won't have any horizontal or slant asymptote. Actually, because there's a 2 degree difference,
Wait, there's no slant?
nope. You have to have exactly 1 degree difference. And I'll tell you why, actually. If all you had was x cubed divided by x,
That would be
what would that be?
x
That
squared
would be
over
x squared.
And what does y equals x squared look like?
Parabola.
Parabola. Everyone had the right hand gesture. That's good. Yes, that would look like a parabola, which means if you zoomed out way far from this function, if you put this function into a graphing calculator and zoomed way, way out, it would start to look like a parabola from far enough out. Because as x gets very, very large, all that will matter is the x cubed on the top and the x on the bottom. This minus 3x will just stop mattering. So it has sort of a parabolic asymptote, but we're not even going to worry about that. Let's see what we can worry about. Okay, first one I said was y-intercept, right? One advantage to foiling it is it does make it easy to see that f of 0 is just going to be positive 2. Is that correct?
Yeah.
Okay. 2, then I said horizontal asymptote, And the answer is none, not even a slant asymptote. This is where if it was a
That's
slant
what
asymptote.
threw me off.
Yeah, that'll do it. I told you guys there just wasn't one if the degree difference was greater than 1, but we didn't go into detail why, or I'm not sure we got to an example of it. After horizontal asymptote, I said x-intercepts, right?
Vertical.
Vertical. Huh. Order doesn't matter that much, but okay. Vertical asymptotes. I pronounced that word horribly. Just the one at x equals 1, because it's a 0 of the denominator. Okay. 4 is x-intercepts?
Yep.
Okay. So let's-
Negative. -1.
Yeah, there's one at x equals -1, gives me a 0 in my numerator. So does +2, but why don't we care about that?
Because it's a vertical, no wait, it's
Yeah, because it's a
Celtic
it's
continuity.
just okay, that's what threw me off. I was so
Yeah.
confused.
There's a jump discontinuity there.
No wait,
So-
point this.
Well, it is still, I'm gonna put it down here. X equals 0, sort of, and I'll show you how that'll play out. Okay? I'll show you how that one will play out. Let's do our sign analysis now. We just need to do it for these 3 remaining factors. Did I spell analysis correct? I'm having one of those days.
Yeah.
Okay. Oops, let's do the x minus 2 first. Now, okay, I care about +2 and that's it. I want to do something a little bit different that I haven't shown you guys here. There's a couple ways to do this, but for the sign analysis, you want to do whatever will make your life simplest. So I'm going to do x plus 1 squared. I'm going to use this whole factor, x plus 1 squared. What's the advantage to that?
You don't have to do 2 different number lines for the same thing.
True, I don't have to do 2 different number lines for the same thing. Also, well, let's see, my point of interest on this is -1. Okay, also if it's squared, will it ever be negative?
No.
No.
No, so all I have to do, since I'm leaving it as x
Mark the
plus 1
0.
squared, mark the 0, very
And then
good.
get the positives.
Got it, Tyler. So that one was easy. And then on the bottom, I'll just worry about the x minus 1.
What do you mean? Why are they all positive?
Well, it's squared. I'm using x plus 1 squared as my factor instead of just x plus 1 twice. And that lets me, I almost said cheat. I don't really think it's cheating. I'm gonna say that lets me be a little more efficient.
It's easy.
Yeah. And now for this one, all I care about is +1. And it's the usual pattern with these binomials. As long as it's 1x, it's going to be negative all the way across. 0 when I get to 2, then positive. And for my x minus 1 factor, that will be negative all the way till I get to 1.
On. Oh wait, in the f max that would be on.
Very good. Then the whole function, wait, this is the y values now. Are they positive or negative?
Wait, so which ones are the numerator? Oh, so the 2 things, the 2 first ones are the numerator and the bottom one's the denominator?
I believe I've set it up that way. Hope so. Yes.
Huh?
Excellent.
All the way up to -1 it's positive.
Yes, it is. Why?
Because there are 2 negatives and they make a positive.
Very good. It's going to be a negative times a positive divided by a negative. So everything to the left of -1 must be positive. Now at -1, I have a 0 in the numerator.
That makes it all zero.
Makes it all 0. Okay, now from -1 to +1, I also have 2 negatives and a positive. Now, at positive 1, I have a 0 in my denominator,
It's
undefined.
undefined.
And from 1 to 2, let's see, at 2 I have another 0 in the numerator.
So that's gonna be negative. Oh,
Wait, where's it going to be negative? I did mess up. Thank you. Thank you. From 1 to 2, it will be negative.
and then anything from 2 is positive.
Very good. Thank you, Noah. Okay, I think we're ready to graph this thing. Okay, we need to care about it. I'm going to sort of 3 units in each direction, so 4. Okay, y-intercept is 0, 2. Horizontal asymptote, none. Too bad, those are helpful. Vertical asymptote, x equals 1. Zeros are at -1. And then there's a 0 here at 2, except are we allowed to fill in the dot? No, that's our point, that's our jump discontinuity. We have to leave that empty. Okay. This is a little bit weird. It's positive. Okay, if our function is positive, there's no horizontal asymptote. It's positive, it has to touch the x-axis here, then it has to stay positive as it heads to this y-intercept. It must do something like that. And since it's positive the whole time, I don't really know what this shape will be.
Yeah, I don't understand how you know what that, like I get on the right side it has to hug the ASCII, but.
Yep. And then it hits there, but not really.
And how do you know, is that because it's negative after 1?
Yes, because it's negative between 1 and 2, I know it hugs it down here. And then it's positive,
On my graph it's like this. On my,
so it goes up somewhere like that.
on my calculator it's like this.
Yeah, okay, I can see that. Yeah. Oh, so it looks more like a parabola, it goes up sharper.
Sort of, yeah,
Oh, that makes sense that it looks more like a parabola, because what did I say? I'm already forgetting what I just said. What did I say this would look like if you zoomed out far enough?
Starts to look up.
So it's like a parabola because you have something cubic, something 3rd degree over something 1st degree. So it should start to look like a parabola on the left and the right.
But is that okay if we don't make it look like a parabola on the right? 'Cause
For tomorrow, yeah. Yeah, for tomorrow's test, I didn't go over that, so that's fair.
That looks like, what do you call that X cube function?
I think this looks a little bit like a cubic. Yeah, it does. It does. Also looks a little bit like a actually, on this side it looks like a parabola. On this side it looks less like I know they look a lot alike, but what looks like a cubic but has an asymptote? Going way back to last fall. What was the other thing that had this sort of shape? Anybody remember?
Cube root.
Cube root goes sideways.
No, not cube root, square root?
It
I
was.
think
It was like,
trigonometry. What was it?
oh, it was no, I know this. It was not
He's gonna get it.
This little one with the shoots.
I think
Tangent?
trigonometry.
Maybe?
Tangent.
Oh.
It was the tangent graph.
I was thinking.
Okay, you should have said tangent. Now remember though, these graphs aren't, even though when they look the same, you can't take a tangent and superimpose it over a cubic. You can't take this and superimpose it over either. But if that helps you remember it. So that's how I would have graphed this one. Alright? Okay, Joey, go ahead and kill the recording, and now I'll give you